So question 2 asks us to identify the property of a gas that's described by each of the following statements. So one thing you'd have to know is what are the properties of gases? And there's 4 of them. There's pressure, which is in the equations given a capital P. There is volume, which in our equations is a capital M. There's temperature, which in equation is given a capital T. And then there's the amount, which is given the letter N in the chemical equation. Not chemical equations, in the equation, the gas laws. So pressure is a capital P, volume is a V, temperature is a capital T, and the amount is a lowercase n. So those are the 4 properties of gases that they want us to identify. So letter A says increases the kinetic energy of gas particles. If you review kinetic molecular theory along with a little bit else of your notes, you will find that it is temperature that if you increase the temperature, it will increase the kinetic energy or the motion of the particles. So letter A is describing temperature. The force of gas particles hitting the walls of the container, that is pressure. In fact, that's really how we think about the definition of pressure, that it's created when the gas inside the container knocks on the walls of the container. And then the space occupied by a gas, that is the definition of what volume is. Volume is how much space a substance occupies, whether it's a liquid, a solid, or a gas. And then on the last 3, we'd be looking at the units. So millimeters of mercury here, that's a unit of pressure. So this 755 millimeters of mercury is describing a pressure. Other units that you would more likely encounter or most likely encounter in this chapter could be atmospheres and then torr. Those are the 3 most common that we use. And then letter E is moles. That's the amount, so that is in. And then K is Kelvin, which is the unit for temperature. Now here, and I'm going to write it in red so you just to try to get you to remember it, and that is that T must be in Kelvin for the gas laws. So often we're given degrees Celsius because that's what we measure in lab. So to calculate the to calculate the Kelvin, you would take that degrees Celsius, which is given to you, and add 273. Well, officially it's 273.15. Now, if you had Kelvin and wanted to go to Celsius, it's you would just have to rearrange the equation. So if you take Kelvin and subtract 273.15, you would go back to Celsius. So on gas law problems, you have to use Kelvin in the equation. Sometimes they'll give it to you in Celsius, the temperature, and ask you to report back in Celsius, but you would have to go into Kelvin, solve your answer, and then then you'd have to come back out of Kelvin by subtracting 273.